Welcome to the viewers. Now we give the idea of the point at infinity in complex plane, and basically this idea is called the stereographic projection. And now the complex plane with the point at infinity given by the symbol this, and we use limits involve it. The complex plane together with this point is called extended complex plane. Now let us draw a figure to clear the idea. If we draw a figure here, it is a sphere centered with z equals to, that means the origin, it is for origin, and another is called north pole here in, and the point P determined on the intersection of the line through the point Z and the north pole of the sphere with the surface, that is called P. This point is called P, and the Z here. So the sphere, if the complex plane, we think of the complex plane as passing through the equator of a unit sphere centered at the point z equals to 0. To each point, that means centered at the point z equals to 0, but here to each point z in the plane, there corresponds exactly one point P on the surface of the sphere. The point P is determined by the intersection of the line through the point Z and the North Pole N. Of the sphere with the surface. In this P, each point P on the surface of the sphere other than North Pole N corresponding one point Z, and by letting this point corresponding to at infinity, we obtained so on the surface. So in the same manner, to each point P on the surface of the sphere other than North Pole N, their correspond exactly one point Z in the plane. By letting the point N of the sphere corresponding corresponds to the point at infinity. And we obtained a one-to-one correspondence between the point of the sphere and the point of the extended complex plane. The sphere is known as Riemann sphere. The correspondence is called stereographic projection. So we give some of the idea about the stereographic projection and these basic stereographic projections that happen in the Riemannian space, here also in complex analysis. Now some of the observing fact: this exterior unit circle that centered at origin and complex plane corresponds to the upper hemisphere of the equator. N will be deleted, moreover each small number epsilon, the complex plane extended system, that is if we consider the circle, mod of z is equals to 1 by epsilon corresponding to the sphere close to n. We thus say mod of z is greater than 1 by epsilon. Epsilon is the neighborhood and of infinity. So we give some of the ideas, and this statement also we call the neighborhood of infinity, that is limit z tends, this statement is called limit z tends to z0 fz equals to infinity, or mod of fz greater than 1 by infinity, whatever maybe it is. Some of the ideas of point at infinity in the complex plane, basically the stereographic projection. That is some of the ideas. If n is deleted, and that means we now really given out the statements limit as z tends to z0, that is fz. If we consider here at w0, and w0 is the neighborhood of infinity, then it is infinity, and that is given epsilon greater than 0, there exists delta greater than 0, such that we consider here mod of fz is greater than 1 by epsilon whenever 0 less than mod of z minus z0 less than delta, or alternatively written, that is mod of 1 by fz minus 0 is less than epsilon whenever 0 less than mod of z minus z0 less than delta. That is limit as z tends to z0 1 by fz is equal to 0. We can write alternative statement. Now we end our discussions here. If you like this video, like it, share it, subscribe the channel. Thanks for watching.